This is part 9 in a series of videos in which I'm developing a 64k SRAM card for the Altair 8800. In the first video I started with a white paper design and outline for what I wanted to design, and then from that point I went through and put together a breadboard version of the design, albeit somewhat simplified. One of the things I didn't mention in the previous videos that once I'd got this working, I optimized the design somewhat. There were quite a few gates in some of the chips that weren't used, so I repurposed them, and that allowed me to remove a couple of the chips and make the entire design more efficient. It also allowed me to optimize the timing of the design as well. Once this was up and running and fully tested on the Altair, I turned that into a PCB layout. I showed that in a previous video. I got some prototype boards ordered, and then I assembled one of the boards. In fact, I assembled two boards and tested them, and in this video I'm going to show you some basic testing and demonstrate the board in operation. So what I'll do is get hold of an Altair, we'll plug this in and I'll show how it works. So I've got the Altair ready, but before I plug the board in, I just want to show a couple of the build options that are available if you decide you want to put one of these together. As I've mentioned in a previous video, the board supports two different footprints for the SRAM chips. They're both 28 pin, but you can get them in either the narrow version, that's 0.3 inch, or the wide 0.6 inch version, and you can also get them in different speeds, so the board will support quite a wide range of these devices, and you can even mix them on the same board. But the build options are you can fit just one or both of these SRAM chips. Doesn't matter which one you fit, but obviously you'll have to make sure that you select the correct RAM chip with the bank switches. And also you can decide whether you want the SRAM to be battery backed. If you want it to be battery backed, then of course you'll need to fit the battery holder and a battery, and also the two management chips as well. Of course, if you're only fitting one of the SRAM chips, then all you'll need to do is fit the battery and whichever of the management chips is required for the particular chip on the board. If you decide you don't want it battery backed, then because these manage the control of the chips, what you will need to do is fit the links that are shown on the silk screen. So if you don't fit these and you don't want it battery backed, you just fit a link between these two pins, and then the same with this chip, and that will effectively make it a standard SRAM card. It supports up to 64k, and what you can do with the switches is just select which of the 16k blocks are enabled, and that way you can mix and match this board with other boards that you might want to test at the same time. So you could use this board, for example, for just the lower 16k, and then you could use this board to test your other memory boards using the programs which can be saved in this board through a power off. So that's what I'll demonstrate next. We'll plug in the assembled board. Okay, so I'll take the board and plug it into the first slot. And what I'm going to do now is power up the Altair, and we'll do some very basic testing in a similar way to the testing we did on the breadboard version. So I'll power up the Altair, perform a reset. So I'll enter an alternating pattern of ones and zeros, and we'll save those to the first few memory locations. Of course, now we have all the address lines and all the data lines hooked up, and then we can examine that data to make sure we get the same pattern read back that we had before, which we do. I'll now do the complement of that, and we'll deposit that in the first few memory locations, and again we'll make sure that we have that data stored in the SRAM, and as you can see we do. So The card is working. I have done a bit of testing on this already and it's looking quite promising. You can go through and load BASIC in the way that you normally do, but as you know, it's a bit of a long-winded process and can take a bit of messing about, and especially if you've got fairly long BASIC programs that you've entered, you either then have to enter BASIC and then load your programs, or you have to type the BASIC programs back in. Of course, with this card, if you've opted for the battery backed version, where you fitted the battery back components, then the data will be retained through a power out. So what I'll do to save a bit of time in this video is I'll pop the card out that I fitted. As I said, I made 2 cards, so I'm going to put the other card in. So I'll get a second card, plug that in, and get it into the slot. Yeah. Okay, so we've now got the second card in. Swapped it. This is the one I've just taken out. And what I'll do now is I'll bring up the terminal program up in the corner of the screen, and so you'll be able to see what I'm doing from the Altair to the terminal program. So we'll start up the Altair, perform a reset, we'll start the Altair running, and then if we look at the terminal program, we have the Altair BASIC loaded, running, and I'll just quickly run a test program, because as I said, it does retain the programs that's entered. So as you can see, BASIC is retained through the power out. Even though I'd removed the board and refitted it, the data that had been previously entered into the Altair is still in memory. This is a RAM card. Now of course this is very different to a ROM card, whereas we can now emulate a ROM card with this, in as much as we can enter programs much more easily than the ROM card, because we don't need a ROM programmer. We can just enter it through the serial port or even through the front panel. Because programs need to be able to read and write to RAM, you can't use a ROM card for this purpose, but this will emulate a ROM card, but you can't do the reverse with a ROM card to emulate RAM. So in other words, this now gives you a very flexible way to enter programs into the Altair. You don't lose them through a power out, and it obviously makes the Altair much more convenient to use. So I'll just go through the process again, just to prove that it's not a fluke and it works repeatedly. I'll pop the card back out. So I've removed the card. Obviously the Altair is off at the moment. I'll put the card back in. Start up the Altair. And we have BASIC up and running again. I'll just quickly run the same program just to prove that it is the same program and that it is still there. So as you can see, a very convenient way to load BASIC or any other system, operating system or software that you want to run. And it's especially useful if you're doing testing on cards within the Altair, where you might want to enter a program into RAM to test the card, and this saves you having to toggle it in every time you boot up the Altair. You just restart the program. Now you noticed I had to start the program twice and reset it. The reason for that, of course, is the way that the 4K and 8K BASIC is organized, is that the boot up section of BASIC is actually overwritten once BASIC starts up. So that's the bit that you see on screen initially, where it asks you for memory size, terminal width, etc. That block of code is actually overwritten when BASIC starts. So when you then subsequently restart it, you go back to the command prompt. But because we aren't running BASIC when we boot up the Altair, what we have to do is start up the program in wherever it happens to be and whatever state it happens to be in. You can then effectively do the same reset that you would be able to do if BASIC had already been running. So that's why I had to start it twice, but it's consistent, it will do that every time and it works fine. So I'll do some more testing on this, and I'll do a follow-up video to show more in-depth testing. I'll run some test programs in BASIC and in machine code and fully demonstrate the card. At the moment it's configured to give me 48k of RAM, and I'll go through and show the entire 16, 32, 48 and 64k operation. If you've got any questions or want me to give any particular demonstrations, then please let me know.